Welcome to Ask and Learn.
In Part A, we are given a linear homogeneous recurrence relation, and we are asked to find the characteristic roots of this relation. The relation is an equals 2an minus 1 minus 2an minus 2. So we have that the characteristic equation is r squared minus 2r plus 2 equals 0. And using the quadratic formula, we have that r is equal to 2 plus or minus the square root of 4 minus 8, which is negative 4, over 2. This is the same as 1 plus or minus square root of negative 4 is 2i. So this is plus or minus I. And these are the characteristic roots. In Part B, we're asked to find the solution of the recurrence relation from Part A with initial conditions a0 equals 1 and a1 equals 2. So to do this, first we have that the general solution, since the roots are distinct, is alpha 1 times 1 plus I to the n plus alpha 2 times 1 minus I to the n, where alpha 1 and alpha 2 are some constants. And in order to find the values of alpha 1 and alpha 2, these are initial conditions. So we have that 1 is equal to 1 plus I to the 0 is 1, so this is alpha 1 plus 1 minus I to the 0 is also 1, so this is plus alpha 2. And we have that 2 is equal to alpha 1 times 1 plus I plus alpha 2 times 1 minus I. Now we know that alpha 1 and alpha 2 could be complex numbers. So the best way to solve this is to subtract 1 minus I of equation 1 from equation 2. So we get 2 minus 1 minus I times 1, which is simply 1 minus I. This is equal to alpha 1 times 1 plus I minus 1 minus I. And the alpha 2's will cancel out. So on the left-hand side, we have 2 minus 1 is 1. So 1 plus I is equal to alpha 1 times 1 minus 1 is 0, and I minus negative I is 2I. So we have that alpha 1 is equal to 1 plus I over 2I. And I'll write this later as a complex number in standard form. First, using back substitution, we have that alpha 2 is equal to 1 minus alpha 1. So this is 1 minus 1 plus I over 2I. This is equal to 2I minus 1 minus I, which is negative 1 plus I over 2I. And now rationalizing a1 and alpha 2. For alpha 1, I multiply the top and bottom by I. So I get I minus 1 over 2. can be written as negative 1/2 plus 1/2 I, and alpha 2 multiply top and bottom by I, and then get negative I minus 1 over 2. This is the same as negative 1/2 minus 1/2 I. And so we have that the solution with these initial conditions is negative 1/2 plus 1/2 I times 1 plus I to the nth power plus negative 1/2 minus 1/2 I times 1 minus I to the nth power. I made a mistake. So when I simplified alpha 1 and alpha 2, in multiplying the denominator by I, the 2 becomes a negative 2. And so this is going to be positive 1/2 minus 1/2 I. And we have the alpha 2, same thing. 2 becomes a negative 2. This is going to be positive 1/2 plus 1/2 I. And so we have that the solution is positive 1/2 minus 1/2 I times 1 plus I to the n plus positive 1/2 plus 1/2 I times 1 minus I to the n. And this is our answer.